In this video, you will learn how to complete a square. Completing the square is a rewriting technique. Let's first look at what it does and where it's from. When you complete a square, you rewrite an expression that contains a quadratic term and a linear term into an expression that contains a quadratic term and a constant term. Lowercase a, lowercase b, capital A, capital B are real numbers, and lowercase x and capital X are variables. There's a very simple relation between the two variables, but they're not the same. So why do we want to rewrite an expression like this as an expression like that? Well, completing the square has many applications. You can solve a quadratic equation. It is in particular used to derive the quadratic formula. You can find the vertex form of a parabola. You can also find the center of a circle, an ellipse, or a hyperbola. Before we go over some example of completing the square, let's look at where it's from. So if you expand the formula x plus a square, which is a square of a sum, you will find x squared plus 2ax plus a squared. You can either FOIL x plus a squared as x plus a times x plus a, but this is also a well-known formula. Likewise, if you expand the square of a difference, x minus a squared, you will find x squared minus 2ax plus a squared. If now you solve each formula for x squared minus 2ax, that means you subtract a squared from both sides right here for both formula. And I will write x squared plus 2ax on the left side. So this is equivalent to x squared plus 2ax equals, so what do you have? You have x plus a squared minus a squared minus a squared. And if you solve the second one for x squared minus 2ax, you have x squared minus 2ax equals x minus a squared minus a squared. Now these two formula are the basis for completing the square. We do rewrite them slightly differently though. Instead of expressing this as 2a, we express it simply as, for example, let's say b, okay? We don't want the 2. So b equals 2a, well that means that a would be b over 2. Okay, so let's rewrite the first formula and the second with the new variable b. So we have the first one becomes x squared plus bx equals, so x plus a, don't forget, a is b over 2. So it is x plus b over 2 squared minus, and a is b over 2 squared, okay? And the second one becomes x squared minus bx equals x minus b over 2 squared minus b over 2 squared, right here, okay? So that's it. These are the formula that you use to complete the square. On the left, you have a quadratic term and a linear term. On the right, there is a quadratic term and a constant term only. Please notice the sign between the quadratic and the linear is the same as the sign inside the square. Oops, I forgot my b right here. It drops out. And here, again, the sign is the same, while the sign outside is always a minus, okay? So let's apply completing the square to some concrete example, and you will see how simple and mechanic it is. So in my first examples, I'm just going to rewrite the sum of a quadratic and a linear term using completing the square. So for example, here, I'm going to use the first formula, x squared plus bx. So how does it work? Well, first, I have this square right here. Inside, I have x plus, now this is b, and in the formula it says b over 2. So 6 divided by 2 is 3. So I write 3 here. This is always a minus. And what do I subtract? The square of the number I just wrote here, minus 9. That's it. It's that simple. Okay, so this number right here is half. This number is half of this one, while this number is always a square of that. Okay, let's do the next one. So now this is a minus, so I'm looking at the second formula. So I have my parenthesis squared right here. X minus half of 10 is 5. And then right here, it's always a minus. I subtract the square of 5, which is 25. All right, let's go over the next one. Okay, so now you see there is a new term right here, but it doesn't matter because you complete the square only on these first two terms, the quadratic and the linear. It doesn't matter if you have something after, right? We'll combine the two constant terms later. So check it out. I'm looking at x squared plus bx. So this is x plus half of 2, 1 squared minus the square of 1 is 1. And then pick up what you had, minus 11. So I just need to combine these two numbers. So it is x plus 1 squared minus 12. All right, next example. In the next example, again, I have a quadratic and a linear here, and I'm going to complete the square on these two terms. So what do I have? I have x. Now this is the second formula, right? The one with a minus. So minus half of 7. So you can write 3.5, which is half of 7, but I rather use fraction because I know how to square a fraction. I'm not sure how to square a decimal number always, right? So 7 half minus, well, the square of 7 half, right? You got to square this number, so that's easy. It's 49 over 4. And then plus 5. Okay, so yes, there is a little bit more work right here. You need to combine the last two numbers. Okay, common denominator. So what is this? This is x minus 7 half squared minus 49 plus 20 is minus 29 over 4. Okay, one more example like that. So what do we have here? We have x minus, half of what? Well, the coefficient of x right here, the linear coefficient is just 1, right? So minus 1 over 2, half of 1 squared. This is always a minus. And the square of 1 half, 1 square is 1, 2 square is 4 minus 1/4 plus 1. Now, negative 1/4 plus 1, that's just 3/4, right? So it is x minus 1 half squared plus 3/4. So in this first series of examples, I just apply completing the square to changing an expression. Now let's apply to other types of problems. Here we go. The first type of problem is solving an equation. What am I going to do? I'm just going to complete the square right here for x squared minus 6x, and you will see how I can easily solve my quadratic equation. So this equation is equivalent to x minus half of 6, 3 squared minus 3 squared is 9, and then plus 4 equals 0. Now please make sure you understand that this and this are exactly the same quantity written differently, okay? But when I write it like that, I can now use it to solve the equation easily. Combine negative 9 and plus 4, so you'll have x minus 3 squared minus 5 equals 0. So this is the same as x minus 3 squared equals 5. Now here, of course, how do you solve x squared equals a if a is positive or equal to 0? So there are two solutions, right? You know that x is plus or minus square root of a. So this is what I'm going to use here to remove my square. And so I have x minus 3 equals plus or minus square root of 5. Finally, in the last step, you will add 3 on both sides, and you have x equals 3 plus or minus square root of 5. All right. See, not too difficult. Let's do another example. Okay, so again, I'm going to solve this equation by completing my square right here. So this equation is equivalent to x minus half of 3. I'm going to write it as a fraction, 3 half squared. But I also need to subtract the square of 3 half. That's 9 fourths. And now, guys, I hope it is clear that these and these expressions are equivalent, okay? So let's not forget the equation, plus 5 equals 0. So now I gotta get a common denominator, multiply both sides by 4. So I have x minus 3 half squared minus, so what do we have? We have minus 9 plus 20. So actually it's going to be a plus. Minus 9 plus 20 is plus 11 over 4 equals 0. All right, let's subtract 11 fourths on both sides. X minus 3 half squared equals negative 11 fourths. Now in this video, I'm only going to be working with real numbers, and I know that a real number cannot be equal to a negative number. That is not possible, not if you work with real number. So this equation doesn't have any solution. So the empty set is your answer. All right, next kind of examples. All right, here's another example where I'm going to complete my square to answer the question. I need to find the vertex form of this quadratic equation. How do I do that? I will rewrite the sum of a quadratic term and a linear term by completing my square. But first I noticed something. The coefficient of x squared, the leading coefficient or the quadratic coefficient, is not 1, it is 2. We have not completed the square with a coefficient different than 1. So what are we going to do? Well, we want to have a 1 right here. So my first move is going to be to divide both sides of the equation by 2. So let's rewrite that. So I have f of x over 2 equals, so you got to divide all three terms here by 2. So we have x squared minus 4x plus 7 over 2. Now I'm ready to complete my square right here. Okay, so what do I have? I have f of x over 2 equals x minus half of 4, 2 squared, minus the square of 2 is 4, plus 7 half. Okay, I need to combine these two numbers, so I multiply both sides by 2 right here. So if and only if f of x over 2 equals, so x minus 2 squared. So this is minus 8 plus 7 is minus 1, minus 1 half. Am I done right here? No. I want to solve for f of x, not f of x over 2. So what do I need to do? I need to multiply both sides by 2 to get rid of the denominator right here. So how do I multiply by 2 these two terms? Easy. In the first one right here, I'm just going to leave the 2 in front of the square. I don't want to bring it inside for sure. And then negative 1 half times 2 is just minus 1. And so we have the vertex form of the equation, which is f of x equals 2 times x minus 2 squared minus 1. Here we go. Let's apply completing the square to another question. In the next question, I have to find the center of this conic. Now, this conic is a circle because the quadratic coefficient for x and y are equal. So I have a circle, all right? How do I find the center? I need to complete the square for x right here, and I also need to complete the square for y. So let's do that. How do you complete the square for x? So x minus 10x is x minus half of 10, 5 squared. Okay, now we're not done. Got to subtract 5 squared, so minus 25. Okay, I've completed the square on the x. Let me do the same on the y. So plus, now y plus half of 6, 3 squared minus 9. All right, I've completed the square on the x and the y. So let's pick up the end of the equation right here. And now what do we need to do? We need to move this on the other side, right? And so we have x minus 5 squared plus y plus 3 squared equals, so 25 and 9, 34, 34 and 5, 39. And on this side, it's plus 39. So what do you recognize right here? You recognize a circle with the center 5, negative 3, and radius is actually square root of 39. All right, last application. So for the last application, we have another conic, but this time it is not a circle because the quadratic coefficient of x is different than the quadratic coefficient of y. They do have the same signs, so it is an ellipse. If they had a different sign, it would be a hyperbola. This is an ellipse. So how do I complete the square right here? I can't just divide both sides by 2 to make this a 1, right? Because then what do I do with 3/2? I make this one more complicated, right? I guess I could complete my square first for x and then do something differently for y, but this is too complicated. One way to do that, I want to complete my square on the x and my y, but I can't because of my quadratic coefficient. So I'm going to factor this coefficient. Now, I did make my numbers a little bit nice right here, but if they're not nice, it's not a big deal. It's very mechanical. It's always the same thing. So take 2 out of the first two terms right here, the terms in x. So you have 2 times x squared minus 6x, okay, and take 3 out of the terms in y. So 3 times y squared plus 18 by 3, 6y. Okay. And now what do? Well, now you're going to complete your square inside the brackets right here. All right, so let's do that. So it's 2 times. Okay, let's complete the square with this one. This is x minus 3 squared minus 3 squared is 9. Okay, plus 3 times. So what is that? This is y plus 3 squared minus 9. All right, and then minus 5 equal to 0. Okay, so almost done. I'm just going to distribute my 2 back so I can finish to rewrite this ellipse in standard form. So what is that? This is 2 times x minus 3 squared minus 18 plus 3 times y plus 3 squared minus 27 minus 5 equal to 0. All right. So what do we have? We have 2 times x minus 3 squared plus 3 times y plus 3 squared. And then we have to put together 18, 27, and 5, and that is 50. So on this side, you will have 50. Now, this is not the standard form of an ellipse, although I do have my center. If the question is just finding the center, I know my center is going to be 3 and negative 3. But if you want to write it in standard form, you know that here you need to have 1. So you divide both sides by 50 to get your 1 on the right side. So what do you have? You have 2 over 50 times x minus 3 squared plus 3 over 50 times y plus 3 squared equals 1. Okay, now usually we write the standard form is written as x squared over a squared plus y squared over b squared equals 1, right? So what do we do right here? Well, multiplying by 2 over 50 is the same as divided by 50 over 2. So x minus 3 squared divided by, well, the reciprocal of 2 over 50, 50 over 2. That's 25. Plus y plus 3 squared divided by 50 over 3 equals 1. Here we go. That's a standard form. It's a little bit more than what the question asks. I hope this video clarifies completing the square. Thank you for watching.